I am going to start inverse trigonometric functions. In inverse trigonometric functions, I will be discussing past year IIT JEE advanced level questions. Let us go to discuss the first question. The number of real solutions of tan inverse under root of x into x plus 1 plus sin inverse under root of x square root plus x plus 1 is equal to pi by 2 is. So these are the four options. We'll see the solution now. Here we have to find the real solutions. So first let me take down the given information. What is given information here? Tan inverse under root of x into x plus 1 plus sin inverse under root of x square plus x plus 1 is equal to pi by 2. If we do some small changes, definitely we will be coming across one of the properties. So I'll tell you the property before that. We are very familiar with this property, sin inverse x plus cos inverse x is equal to pi by 2. If minus 1 less than or equal to x less than or equal to 1. Here right side I have noticed pi by 2 is presenting. By taking the support of this identity, definitely we are going to solve this question. Now see here, just consider one right angle triangle here. I would like to define tan inverse here. Here tan inverse is nothing but opposite side. What is opposite side? Under root of x square root plus x upon adjacent side I will write 1. By Pythagoras law, I would like to find the hypotenuse here, which is nothing but the square root of side square plus side square. Side square plus side square. By using Pythagoras law, I have written here under root of side square plus side square. Now we know the three sides of the right angle triangle here. Now here I would like to convert the first term in terms of cos inverse. I would like to convert tan inverse in terms of cos inverse by taking the support of this right angle triangle here. How to convert in terms of cos inverse? Just so simple here. Adjacent side by hypotenuse. Adjacent side is 1 upon here hypotenuse is under root of x square plus x plus 1. Now it seems to be cos inverse x plus sin inverse x is equal to pi by 2. I have come across this form. I have changed it into this form. So given information has been changed into this form. Here right side part is pi by 2. Here right side part is pi by 2. That means I can say simply in place of x what is lying here? Under root of x square root plus x plus 1. In place of x what is here? 1 by under root of x square plus x plus 1. But right side part clearly pi by 2. If it is going to be pi by 2 means these two parts must be equal. If it is going to be pi by 2 means these two parts must be equal. So what we have here? X we have. What we have here? X. So that means sin inverse x plus cos inverse x is equal to pi by 2. So based on this property, I may say they must be equal. If I equate these two terms, if I equate these two, what I am getting, you know, x square plus x plus 1 is equal to 1. If I equate these two terms, I have got this one. Next, numerical values get cancelled here. Finally, what is left? X square plus x is left. X I am going to take common. Then x into x plus 1 is equal to 0 we have got. So that means I have got x is equal to 0 and x is equal to minus 1. X is equal to 0 and x is equal to minus 1. See, x is equal to 0 and x is equal to minus 1, both are lying in this interval. Both are lying in this interval. Sin inverse x2 plus cos inverse is equal to pi by 2 will hold only if minus 1 less than or equal to x less than or equal to 1. So whatever the values I have got, x is equal to 0 and x is equal to minus 1, both are lying in this interval. So that means how many real solutions are possible means, I will say with confidently 2 real solutions are possible. I will say with confidently 2 real solutions are possible. Suppose if you are having any doubt, simple technique I want to tell you. See here, x is equal to 0 for example you take. Substitute in the given information. In place of x, when you write 0, tan inverse 0 is going to become 0. Plus, when you write in place of x 0, it is going to be sin inverse 1. Sin inverse 1 is nothing but pi by 2. So what we have on the right side? Pi by 2. So that means LHS is equal to RHS. That means we have got the real solution. So similarly, I am going to check for x is equal to minus 1. When I substitute x is equal to minus 1 here, it is going to become tan inverse 0. So tan inverse 0 is nothing but 0 plus, when I substitute here, in place of x minus 1 plus 1 get cancelled. Here minus 1 whole square means plus 1, root of 1 means 1. So finally it is going to become, when I substitute x is equal to minus 1 here, it is going to become sin inverse 1. Sin inverse 1 is nothing but pi by 2. What we have on the right side? Pi by 2. That means both the values, whatever I have got, they are going to satisfy. Clearly I can conclude this given information has 2 real solutions. I hope that you have understood this question very clearly. Let us go to discuss another question. If 0 less than x less than 1, then under root of 1 plus x square into, see the innermost part here, x into cos of cot inverse x plus sin of cot inverse x whole square minus 1 whole power 1 by 2 is equal to, these are the 4 options. We'll see the solution for this question. What is given here? X lies between 0 and 1. We have to find its value. First let me note down the given information. Under root of 1 plus x square into, just I am noting down the given information here, x into cos of cot inverse x plus sin of cot inverse x whole square minus 1 whole power 1 by 2. So this is the given information here. This is the given information. Now, here I have noticed innermost parts cot inverse x. Just consider one right angle triangle for them. How to define cot inverse x? Adjacent side by opposite side. By using Pythagoras law, hypotenuse can be found, which is under root of 1 plus x square. Now, cot inverse x should be expressed in terms of cos inverse here. Cot inverse x should be expressed in terms of cos inverse here. How to express? Adjacent side by hypotenuse. then cos and cos inverse get cancelled. Next, I would like to express here cot inverse x should be in terms of sine inverse. How to express in terms of sine inverse? Opposite by hypotenuse. Then sine inverse and sine get cancelled here. Finally, what is left I am going to write here. Finally, what is left here? X into x, x square upon under root of 1 plus x square. Here what is left? Only plus 1 upon under root of 1 plus x square. This part is left. Just keeping the brackets, so taking the power 2 here, whole square. When I simplify this part by taking the LCM, I am going to get numerator is going to become x square plus 1. Denominator is, both the denominators are same na? Denominator will be under root of 1 plus x square only. It is of the form a by root a. Root a. When I apply the square here, it becomes a. Here a is nothing but x square plus 1. That means I have simplified the part which is lying between the curly brackets. So finally, between the curly brackets, what I have got here, x square plus 1. Have you seen minus 1 is presenting outside of the curly brackets? Plus 1 and minus 1 get cancelled. So finally, x square. Finally, what is left here? X square. So x square whole power 1 by 2 is nothing but x. X square whole power 1 by 2 is nothing but x. This part, we did not disturb this part. Here x should be multiplied by under root of 1 plus x square. So this is the final answer I have got for this question, which is available in option C. I hope that you have understood this question very clearly. So it is completely competitive. Let us go to discuss another question. If alpha is equal to 3 into sine inverse 6 by 11 and beta is equal to 3 into cos inverse 4 by 9, where the inverse trigonometric functions take only the principal values, then the correct option is or then the correct options are. That means clearly it is more than one correct answer type question. We will see the solution for this question. So alpha value given here. Here alpha is equal to 3 sine inverse 6 by 11. Beta is equal to 3 into cos inverse 4 by 9. So that means we have to check these options here. First option cos beta greater than 0. Second option sin beta less than 0. And third one cos alpha plus beta greater than 0. Fourth one cos alpha less than 0. Now I would like to consider this part. That means 6 by 11 I would like to consider first. I have taken 6 by 11. I would like to compare with 1 by 2. When I apply cross multiplication here, clearly it is going to be 12, it is going to be 11. So 12 is greater than 11. I would like to use the symbol here greater than. So 12 is greater than 11. Now taking sine inverse on both the sides. Now taking sine inverse on both the sides. Next, multiply with the 3 on both the sides. And we know that sine inverse 1 by 2 is nothing but pi by 6. When I multiply with the 3, it is going to be pi by 2. So finally, in place of 3 sine inverse 6 by 11, what I can write here? Alpha. Alpha clearly greater than pi by 2 I got. So alpha greater than pi by 2 I have got. Now let us go to check the options here. Alpha greater than pi by 2 means here all the inverse trigonometric functions take only principal values. That means alpha belongs to greater than pi by 2 means I can write alpha belongs to second quadrant. In second quadrant cos is negative. That means D is the correct option here. Now consider this fraction 4 by 9 here. Now consider this fraction 4 by 9. So I would like to compare with 1 by 2 again. So clearly 8 is less than 9. If I take a cos inverse on both the sides, I would like to take cos inverse on both the sides. Less than will become greater than, because cos x function is clearly a decreasing function. Now I would like to multiply with 3 on both the sides. In place of cos inverse 1 by 2, what I can write? Pi by 3. Then 3 get cancelled here. In place of this value, finally what I can write? This is nothing but given information beta. So that means beta greater than pi I have got. This implies beta greater than pi means beta belongs to third quadrant. Beta belongs to third quadrant. That means cos is negative here. In third quadrant cos is negative. But in option cos beta greater than 0 given. That means eliminate that one. Next, if I take a sign, in third quadrant sign is negative. Beta belongs to third quadrant. So sin beta less than 0. It is correct option it is. Now only one option is left to, which is cos alpha plus beta greater than 0. I have to check whether it is correct or not. For that I have to consider first alpha plus beta. Here alpha value I have got, beta value also I have got. What is alpha here? Alpha clearly greater than pi by 2, beta clearly greater than pi. That means alpha plus beta clearly greater than 3 pi by 2. So from this information, alpha plus beta belongs to greater than 3 by 2 means Q4. That means fourth quadrant. If I consider cos alpha plus beta, in fourth quadrant cos is positive. That means cos alpha plus beta greater than 0. So clearly it is available in third option. Now what I want to conclude. So from the given informations, I have got 3 options are correct out of the 4. I hope that you have understood this question very clearly. Now let us go to discuss another question. Let x comma y be such that sin inverse ax plus cos inverse y plus cos inverse bxy is equal to pi by 2. So clearly it is a match the columns type question. Items of column 1 have to be matched with items of column 2. Right. So first we will see the solution here. So what is given here? Sin inverse ax plus cos inverse y plus cos inverse bxy is equal to pi by 2. This is the given information. We will see the first question here, capital A. We will see the first question, capital A here. A is equal to 1 and B is equal to 0. Right. If A is equal to 1, first term is going to become sin inverse x plus there is no change in the second term, which is cos inverse y, plus in place of B I have to write 0. Then cos inverse 0 is nothing but pi by 2. Already we have pi by 2 on the right side. So then pi by 2 get cancelled. Now if I send this term towards the right side, it is going to be minus cos inverse y. Minus as it is I have written, cos inverse y should be expressed in terms of sin inverse. So cos inverse y can be equal to sin inverse under root of 1 minus y square. Then sin inverse get cancelled here. Finally, what is left here? X is equal to minus under root of 1 minus y square. Squaring on both the sides. Then x square is equal to 1 minus y square. Finally, what I have got? X square plus y square is equal to 1. So that means for the question capital A, what I have got? X square plus y square is equal to 1. That means x comma y lies on the circle x square plus y square is equal to P. So for this question we have got P. That means capital A has to be matched with P. Now we'll see the second question, capital B here. What is B here? A is equal to 1 and B is equal to 1. When I substitute here, in place of A, 1. That means first term is going to become sin inverse x. There is no change in the second term, which is cos inverse y, plus in place of B I have to write 1. Third term is going to become cos inverse xy. That is equal to, I am sending first two terms towards the right side. First let me write cos inverse xy. That means the third term I have written as it is. So cos inverse xy is equal to, if I send this term towards the right side, it is going to be pi by 2 minus sin inverse x is nothing but cos inverse x. I have already decided to send this term towards the right side. It will become minus cos inverse y. Now cos inverse x minus cos inverse y can be written as cos inverse xy plus, here minus sign we have now, its opposite sign we have to consider, xy plus under root of 1 minus x square into under root of 1 minus y square. Then cos inverse get cancelled. Okay. Next, what is left here? This is the remaining part here. Next, xy get cancelled. Finally, squaring on both the sides. 1 minus x square into 1 minus y square is equal to 0. This is the part I have got. That means for the question B, here x comma y lies on x square minus 1 into y square minus 1. Very simple here. Just taking the minus common here from both the factors, we get x square minus 1 into y square minus 1. I have taken minus common from both the factors here. I got for the question B, what is the correct option here? Q. That means B, capital B has to be matched with Q. Now we will discuss the question number C here. Right. If A is equal to 1 and B is equal to 2, then x comma y. Substitute here. First term is going to become sin inverse x plus, there is no change in the second term, which is cos inverse y, plus in place of B I have to write 2. Third term is going to become cos inverse 2xy. So right side part to pi by 2 as it is. Next, first send this term towards the right side. Then pi by 2 minus sin inverse x is going to become, then pi by 2 minus sin inverse x is going to become cos inverse x. Next, send this term towards the right side. First let me write the third term, cos inverse 2xy, that is equal to right side part. What is the right side part here? Cos inverse x minus cos inverse y. So that is equal to cos inverse We have the direct formula for this. Cos inverse x minus cos inverse y is nothing but cos inverse xy plus, here minus sign is there, na? We have to consider plus sign, under root of 1 minus x square into 1 minus y square. So cos inverse get cancelled. So finally bring this xy to the left hand side. Then it is going to be 2xy minus xy, that is nothing but xy. Xy is equal to under root of 1 minus x square into 1 minus y square. Next, squaring on both the sides. This implies x square y square is equal to, here squaring, direct multiplication, 1 minus y square minus x square plus x square y square. Here x square y square get cancelled. Finally I have got x square plus y square is equal to 1. So finally what I have got here, x square plus y square is equal to 1. That means x comma y lies on the circle. Again C has to be matched with P. Already A had been matched with P, B had been matched with Q. Just now we have got C has been matched with P. Now one more question we have, that is D. What is D here? If A is equal to 2 and B is equal to 2, then x comma y. Let us substitute here. First term is going to become sin inverse 2x. There is no change in the second term. Third term is going to become cos inverse 2xy. So that is equal to pi by 2. That means in place of A and B, I have written 2. Right. So first send this term towards the right side. Next send this term towards the right side. Let me write the third term as it is. Cos inverse 2xy is equal to, so pi by 2 minus sin inverse 2x is nothing but cos inverse 2x. Pi by 2 minus sin inverse 2x is nothing but cos inverse 2x. If I send this term, it becomes negative. It is going to become minus cos inverse y. Here we can apply the formula cos inverse. Very simple. Multiply these two terms, 2xy. Here opposite sign we have to take plus, under root of 1 minus, square this term, 1 minus 4x square. Next under root of 1 minus, do the squaring here, y square. Next cos inverse get cancelled, 2xy get cancelled. Finally squaring on both the sides, 1 minus 4x square into 1 minus y square is equal to 0. So that D has to be matched with yes. D has to be matched with yes. So taking minus common from the two factors, we can write like that also. So which is nothing but C. That means capital D has to be matched with yes. So it is clearly match the columns type. So here I have covered almost 4 questions. So just by taking the support of basic formulas only, I hope that you have understood this.